Hi, everyone. What we're going to go through today is a quick intro to Materialize and DBT, and then a walkthrough of using the DBT Materialize adapter to create and maintain a real-time Materialize view on some example streaming data. And then we'll close with some Q&A. So just to give some quick introductions to who will be talking today. I'm Andy, and I work in community at Materialize. Jessica Laughlin will be running through the core of the demo, the DBT Materialize adapter, and is an engineer here at Materialize. And we have a guest star, Amy Chen, who will be giving an intro to DBT. Amy is a solutions architect at Fishtown Analytics, which is the company that builds DBT. And you can find all of us on the Slacks. We're all both on the DBT Slack, which is huge and amazing, and I encourage everyone to join. And the Materialize Slack, which is smaller but growing and a good source of Q&A for Materialize specific stuff. So let's get right into Materialize. There's not a great category name for it. Stream processor or streaming database come loaded with some meanings that for a technical understanding are not quite right. So bear with me through this explanation where we're going to break down the statement of Materialize as an engine for maintaining views on streams of fast changing data. When we're talking about streams of fast changing data, we're talking about event streams or message brokers like Kafka and Kinesis. This is the main source of data coming in to Materialize. But we can also process in archived events from S3 or local files. And we actually just recently added a PubNub source, which is good for demonstrations like the one today. So we'll be using that today. And that's just another SaaS provider of streaming data that has some really nice example data feeds. And the formats of those events are everything you would expect from message brokers like JSON, Avro, or even just text bytes. And if you're not already a big user of Kafka and Kinesis and you're coming from the data engineering world, something that's coming soon that might be really useful is a direct Postgres source where instead of having a couple other services that are translating events from your database into Kafka, you can just connect Materialize directly to your Postgres database and use it as if you were creating real-time views or creating Materialized views in Postgres, except they're a lot better in Materialize. And just to cover the types of data that Materialize handles well, change feeds from databases, which is this change data capture concept that's growing fast, are really the first class use case, but there's a ton of other types of fast changing structured data from web analytics and mobile and gaming and IoT that can also be materialized into real-time views just as well. And then additionally, if you're using an event-sourced architecture where Kafka is kind of the spine of your business's architecture, then you probably have a lot of data in Kafka, which it would be very useful to materialize. And then I think everyone coming from the DBT side will be familiar with views, but what we mean here, a materialized view is in its most practical form. If you think about like an Excel spreadsheet where you have a big data worksheet tab and then a pivot table or a summary table in another tab that's distilling that's a materialized view. But in Materialize, this is just about distilling the raw data into whatever form that you need. And this is done in Postgres compatible SQL. And the big difference between all other Materialize views and what we have here is it's updated in real time and the results can be queried or streamed out. And to dig a little bit more into that real-time aspect, under the hood, Materialize is using something called incremental computation, which is the timely data flow and differential data flow technologies that it's built on if you read about those. And what that does is it enables us to keep the views continually updated. So when one new piece of information comes in, the work to update the views is proportionate to that new data, not the entire complexity of the view. In a lot of traditional materialized views, if you want to update it, you need to do a full scan of the database or all of the data affected. In this case, it sort of flips that, and that allows it to be much faster and put no load on the upstream databases. And lastly, it's an engine because it runs as a single binary and it presents as Postgres. You connect to it with pSQL and many other SQL tools and integrations like DBT, what we're talking about today. And users specify what they need in SQL and the engine handles how to get it. So that's where it differs a lot from a stream processor where you would be writing more of the how in code. And it's more of a query engine than a storage engine. The views are materialized in memory. And so all of the data that you want to materialize has to be available in Kafka or your upstream database. And then what can you do with Materialize? You can build better data products. So the two worlds of data engineering and software engineering are sort of converging, but dividing it up by these two worlds into some example use cases. Things like real-time analytics dashboards are often the first thing that people are able to build with Materialize, but you can move on pretty quickly to operational analytics where you're taking the human out of the loop and automating decision-making based on analytics, and more of the data products type of stuff, like if you're building real-time enrichment or internal analytics APIs. And then from the software engineering side, real-time applications, user-facing real-time analytics, anything where the amount of data is the biggest constraint in the application, Materialize can often help. So with that, I'm going to hand it over to Amy to talk through DBT.
Awesome. Do you mind forwarding, I think, 2 slides? It's my first slide. Awesome, thank you. So before we actually show off the adapter, I wanted to give essentially a quick primer on what DBT is, especially for the folks here that are coming from the Materialize side of things. So DBT stands for Data Build Tool. We essentially created it with the intention to enable folks who are comfortable with SQL to be able to author their own data pipelines. With DBT, you are able to enable data analysts or data scientists to essentially work like software engineers by giving them access to a analytics engineering workflow, including things like testing and version control. Now on to the next slide. Thank you. So the key thing I wanted to talk about here is how DBT actually works as a transformation tool. So DBT is able to orchestrate your SQL data pipelines inside of your data warehouse. If you're coming from, say, a more traditional ETL tool, the difference is we essentially push down all that compute into your data warehouse. What it essentially looks like is we issue a command to the warehouse that'll tell the warehouse actually how to transform the data. And then once that transformation is complete, it'll let us know if that transformation was actually successful or not. Now, digging a little bit deeper, I wanted to touch upon some key features that folks are using, like essentially how folks are using DBT and how it might look like in application. So testing and documentation are definitely the key ones folks are eager to get their hands on. In the past, people might be essentially manually testing data validity. I know I've lived in the world of 8,000 row Excel sheets and VLOOKUP to essentially check my output. Now, if I'm able to write that test in SQL, I can implement it as part of my CI/CD process with DBT. In terms of documentation, with DBT, you're able to essentially generate a doc site that will include a full lineage graph and metadata. How we're able to do this is we take all the information you feed to DBT, either through description fields or using something we call the ref function to automatically declare model lineage. And then we combine that with the metadata that we're able to extract out from your data warehouse and then put that in a consumable site that you can also host yourself or we can host for you. We're also integrated with Git, so you can version control your analytics code. So you can take full advantage of a Git workflow for your analytics space. And also because everything is done in code, you can just work more modularly. An example I often like to share, especially if you're working on the more data engineering side of things, is say you have a snippet of code that you run very often, or you have code that you're essentially utilizing in multiple places, but it's exactly the same. I know all of us have a create or drop statement hidden somewhere that we just paste in all the time. Rather than creating or copying and pasting that over and over in DBT, you're able to create something called a macro. And then what you can do with that macro is you can call it whenever you need it. This way you're not copying and pasting, or if your logic ever changes, you're actually just updating it in one place. With working with Materialize, it's quite possible that you find yourself writing the same create statement as part of your workflow. So what you're able to do now is just write it in DBT and then tell DBT to actually run that macro rather than rewriting it or copying and pasting it into the command line. There are definitely a lot more features than we have time to speak about. So I wanted to just leave with one more piece of information. So next slide, which is centered around DBT interfaces. So there's actually two ways you can use DBT. One is DBT Core. This is when users essentially interface with it using the command line. This is our open source product. It's completely free to use. It's generally geared towards a more technical crowd with a lot of Git experience and are just interested in being able to customize what tools they want to use. The other is DBT Cloud. This is a fully managed SaaS product. With it, you're able to handle all of your DBT project from development to deployment all in a single browser-based tool. It comes with a develop interface, which is generally accessible to folks who are new to Git, as well as you can orchestrate your production pipelines, whether it might be through regularly scheduled jobs or using our API. I should also probably note that it's not an either or situation. We have plenty of folks who use both for different use cases. It just really depends on where you want to spend your time and team dynamics. In terms of Materialize, we currently have that adapter available for beta for DBT Core. We do hope to support the adapter in DBT Cloud in the near future. So do keep a lookout for it if you're interested. Now I'm going to turn it over to Jessica, who I think is talking about the adapter.
Hey, can everyone hear me?
Yep.
Awesome. Sorry, Zoom. So thank you so much to Andy and Amy for introducing Materialize and DBT. I'm going to walk through the DBT Materialize adapter, which is what lets you connect DBT to a Materialize instance. So to start with, what is a DBT adapter? Amy just mentioned what DBT is, and the unit of, a project in DBT is a DBT project. So you define all your transformations, you bundle it up, and you have something that connects to an underlying data warehouse. But that's a bit of a simplification because you actually have a DBT adapter in the middle, which translates the SQL that you've written in your DBT project to SQL that can be executed against the data warehouse. In this case, this means Materialize. So the DBT Materialize adapter connects DBT to your Materialize instance. And why would you want to do that? You'd want to do that because using the DBT Materialize adapter is the only way to transform streaming data in real time with DBT. If you're familiar with DBT, there are 4 ways that you can materialize your data right now. So these are the 4 materialization options. Materialization dictates how DBT persists your data transformation into your underlying data warehouse. Right now, a table persists a table, a view queries using a view, an ephemeral model queries using a CTE, which is a common DBT pattern, and an incremental materialization creates a table with refreshes, which for those of you who are familiar, it's sort of like how traditional databases implement materialized views today. So while all these correctly transform your views and can persist data, it is more attuned to batch data, not streaming data. For those of you who are like, wait, there's another way, Amy Chen actually wrote the unofficial Lambda view way to transform your streaming data in real time. There's a blog post about it. It is sort of similar to a table with refreshes, but a little bit more efficient. So although every time you query something using this Lambda view materialization, you will be up to date, you're still paying a cost. So DBT Materialize is the only adapter right now to provide a materialized view materialization. And this means that when you use DBT and Materialize together, you can create the incrementally maintained materialized views that Andy was talking about earlier in this presentation. So as new data flows in to your views and your sources, we're going to keep everything up to date for you. And this means that you can DBT run your models once and never run them again. So as opposed to the incremental materializations that you have to keep refreshing or the Lambda view approach, you really just have to set up DBT with Materialize, run your models, and we will be persisting your data in an incrementally updated fashion. So this reduces the CPU cycles. This is basically the most efficient way and the only way that you can transform your streaming data in real time. And as Andy mentioned, I have a little demo project that I'm going to show off. It is going to read in PubNub data, For those not familiar, PubNub is a really easy publish-subscribe service, and they have some free data streams available online, which we're going to use for this. We're going to stream PubNub data into a Materialize instance that's running locally on my laptop. Then we're going to use DBT to transform the PubNub data as it comes in, and I'll show that this is being transformed in real time, that it's up to date within millisecond latency, and that I only have to run DBT once for that to happen. Great, so I'm just gonna switch over to, I got a helpful tip from my friend Brian, who may or may not be in this call at the moment, but we actually pre-recorded this demo. So I'm just gonna hit, sorry, let me do it with audio. That's important. And so we pre-recorded this demo with the demo project with PubNub. I'm just going to hit play, and then we will be available to answer any questions later. This project and other projects are available on our GitHub, so you can get started playing with DBT and Materialize. So I'll just play. Hey, Andy, could you just confirm that you can see my video screen?
Yep.
Awesome. Thank you so much.
Let's take a look at the sample project that I've written up that will allow us to stream PubNub data into Materialize and then transform that data using DBT. Because we're using PubNub data, I named this PubNub DBT in the project's dbt project.yaml, which is the highest level config for a DBT project. I created a new PubNub profile for this project. For those of you not familiar with DBT profiles, this is the way that you tell DBT how to connect to your data warehouse. So if we want to take a look, I'm looking at my dbt profiles.yaml on my local computer, and I have this PubNub profile, which this project is going to use, and you can see that the data warehouse type here is Materialize. So this is what tells DBT to dispatch to the DBT Materialize adapter in order to connect and perform transformations. The rest of the configs here just tell DBT how to connect to the Materialize instance. For those of you familiar with Postgres, these are identical to Postgres. Materialize in general tries to be Postgres compliant and is in many cases, so this is one of those. The SQL transformations that we're going to be running on top of the PubNub data live in their own model files, and they are in the models directory of this DBT project, which is standard for DBT projects in general. So let's look at our schema.yaml file, which is in that models directory, and defines our source and our models at a high level for the project. So we have one source of data, which we've discussed, this PubNub data, and we're going to use their market order stream. So this is a stream of bid price, order quantity, symbol, and it just keeps coming in. So this is the data we're going to be streaming into Materialize, and we're going to call that market orders raw. We then define three models, the first of which is market orders. So when that data is streaming into Materialize, it's just coming in as a text blob. So this market orders view is just unnesting and casting that text to meaningful columns that have data types. The next two models here are actual analytics models. The first is average bid, which is going to calculate the average bid amount by symbol. So per stock symbol that we see, what is the average price over time? So this is going to be persisted into Materialize and maintain correct results as new rows stream in. Similarly, we're going to have a top movers view, which will have the quantity of shares purchased by symbol. So we have the symbol, we have the quantity, and instead of an average, this is going to be a sum aggregation over the streaming data. On all of these, I have defined probably the most basic test, which is that the data streaming in should never be null for any of these fields. Test is one of the great DBT features. There are lots of things you could do here, especially with numbers, but you can add data tests, but I'm just going to add the simplest one to show off DBT test a little bit later. So let's take a look at the individual model files for each of these models, which you can see here. So first we have the market orders model. This is what's pulling in the text raw from PubNub, translating that to JSON, and then breaking that into reasonable columns. So symbol, as you might expect, is going to be text. The bid price is going to be cast to a float, and the order quantity is going to be cast to an int. This is what will allow us to perform useful aggregations on this data from PubNub market orders raw. For those of you not familiar with DBT, this config, Materialized, is what tells DBT how to persist your data, or your transformed data, into your underlying data warehouse. If you remember, I mentioned that the traditional options are table, view, incremental, and ephemeral. The DBT Materialize adapter is what adds this Materialize view option. So when you say materialize my transformation as a materialized view, that is what persists a Materialize view into your running Materialize instance. That means that this view, or this select statement, is going to be wrapped up in a create view statement that will be incrementally maintained as new rows float in. And I'll show that off a bit later. Average bid is the first of our analytics queries, and it's just going to select a symbol, maintain an average aggregate price of the bid price, and also be a Materialize view. Materialize, and then we have top movers, which similar to average bid has the symbol, but instead we're just going to maintain a sum over time. This will also be a Materialized view. So now that we have our DBT project, let's run it. I'm on my local machine. I'm going to navigate to the pubnub.dbt directory, and then I'm going to create a virtual environment to execute my DBT commands. I'm going to spell it correctly. Cool. So now I'm in my virtual environment, and all you need to do to run DBT with Materialize is pip install dbt materialize. So that's our Python package that contains our Materialize adapter. It's in PyPy. It's also in our main GitHub repository if you're ever curious and wanted to take a closer look at it. And then while that's running, I'm going to get a Materialize instance up and running on my laptop. So I built from source. I'm going to run this Materialize binary that I have locally. Right now, you have to run Materialize locally, although we're launching a cloud product, which Andy will promote a little bit later on. So that's up and running in the background. That screen doesn't do anything interesting, so I'm just going to hide that for now. But what we do need to do is we've created a few models, but we need to set up the original stream of PubNub data so we can build our models on top of that. So I'm going to create a new schema in Materialize. This was connected to Materialize through pSQL called PubNub. Okay, that already exists. Cool. Take two. Creating a schema called PubNub. And then I'm going to create a source called PubNub Market Orders Raw. So this is what we saw, the raw text that's going to be coming in from PubNub. Okay, perfect. So we have our source up and running. It is now currently streaming data into Materialize. So what we want to do here is use dbt to persist the transformations that we've defined in our model files into the Materialize instance. So the first thing that we can do is just make sure that dbt can connect to Materialize, which I did using dbt debug. And it can. So great news, it found my Materialize instance at localhost, everything's okay. It found it in the profile.yaml, it found my dbt project.yaml, so it knows what models to run, so we're good to go. The next thing I'm going to need to do is compile my SQL. So a cool feature of dbt is that it lets you insert Jinja into your SQL files. This compile command is what turns the Jinja SQL into actual. Nice. So that worked. And now we are just going to run those models. So dbt run is what reads the model files, runs the SQL, and actually persists the transformed data into your underlying data warehouse. Ta-da! Okay, so now we have an analytics market orders, an analytics average bid, and an analytics top movers. You can see they were all persisted as Materialized views. So, oops, didn't need to do that, but let's take a look at them. So the first one that isn't super interesting, but the view that is transforming the text into a table with reasonable columns is this market orders view. So you can see we have some symbols. They all happen to be Apple so far. They have their bid price and they have their quantity. So this is the view we're building on top of as the new data streams in. The more interesting views, the first one is this average bid. If you remember, we're maintaining the average bid per stock price, and awesome. So up to the point where I ran that query, the average bid price for Google was $304. But because new data is streaming in, it changes. So Materialize is doing that work behind the scenes to maintain that average. So we didn't need to tell the view anything in order to update. We didn't need to refresh it. We didn't need to rerun it. Materialize only performs work on new data as it arrives if it will affect the output of the view. So a cool way to see this actually is with a handy watch command that I'm going to run. So this is really the magic of Materialize. We are not doing anything for this price to be updating. I mean, we're running a watch command, but the view itself, the underlying view, is changing in real time as data flows in, and we are maintaining an up-to-date average of the price as that happens. Those of you more familiar with Materialize know about this. You probably have more complicated analytics queries. In particular, we're great at joins, so this might seem a bit simplistic, but for those of you not familiar with Materialize, this is kind of the magic that we perform. We can also take a look at the top movers. If you remember, the top movers is just the quantity of shares being purchased. So you can watch that climb over time, just like the average. This is being maintained incrementally. So you're transforming your data in real time using DBT, using Materialize, using our adapter. You are only performing work when necessary, which is what differentiates creating a Materialize view in Materialize versus using DBT's incremental models or the Lambda view approach. This is really minimizing the CPU and memory work, or the CPU work and the memory, while still maintaining up-to-date views within milliseconds. So I hope you're all wowed. And then I'm just gonna leave that running down here for a second and get back to the other DBT features. So there are a handful of DBT commands that are useful and that you might want to use, and we support all of them. So we showed off DBT compile, DBT run. Another one that I mentioned briefly earlier is DBT test. So this runs the tests that we defined. They were all pretty simple, they're not nulls, but they passed. You can define more complicated things, which you probably should, and I'm happy to explore that with anyone if you're using DBT and Materialize and you want to get going with that. Another thing that you will likely want to do is use DBT's doc. So that's the purpose of writing information that is useful in your schema.yaml. So DBT will use these descriptions and information that you provide in here to generate like really useful docs. And that's all you need to do to get them. Auto-generated documentation. So we have one source, which is our market orders raw. You can see that it's the text, so that's why we needed to break that out. We have 3 models, our market orders, our average bid, and our top movers. Each of these pages will contain detailed information about that model, as per usual. So this is standard for DBT, but just pointing out that it works with Materialize. And you can maintain these lineage graphs, which I've heard are super helpful to folks and makes a lot of sense when you have more than 2 analytics views and you want to understand where your data is coming from. So that's really the demo. That's how you connect DBT to Materialize, how you persist your data transformations as Materialize views, and how you keep your streaming data transformed and up to date in real time.
Awesome. So that was the demo, like the pre-recorded me mentioned. We have some demos available in our GitHub repository. We have one with Wikipedia data, for example. Feel free to reach out to anyone in the Materialize Slack and the DBT Slack. We have our own channel, but hopefully that was a helpful overview to illustrate how you'd get started with DBT and Materialize and why you'd want to use us together. We do have at least one person using DBT and Materialize in production. We have a few more testing it out. So we're super eager to get more people using us together and also to get any feedback. We've gotten great feature requests and thoughts from people who have used it so far. Andy, is there something else you wanted to say?
Nope. I think if you go to the next slide, I think there's a quick shout out for the cloud. So like DBT, Materialize has a source available, or in Materialize case, our product is source available, kind of similar to Mongo, where anyone can download and run Materialize locally, like you saw Jessica do, and use it free forever in a single node configuration. And there's also a cloud version if you don't want to manage your own instances that's currently in private beta. If you are interested in testing that out, go to materialize.com/cloud and register there, and we'll make sure we get everyone in this demo access as quickly as possible.